The angle of inclination, or simply the inclination of a line, is the smallest positive angle from the positive x-axis to the line. This is our x-axis, and this is our line. The angle of inclination is from the positive x-axis going to the line, same as with this figure. This is the x-axis, this is the line, and the angle of inclination is from the positive x-axis going to our line. The slope of the line is the tangent of the inclination. Mathematically, we have the formula. M as the slope is equal to tangent theta. The slope is the ratio of the rise to the run. Thus, given 2 points, P1 with coordinates x1, y1, and P2 with coordinates x2, y2, the slope of the line is given by this formula. Slope M is equal to y2 minus y1 over x2 minus x1. The concept of slope is very useful in the study of analytic geometry, especially those involving lines. Now we will learn about the parallel and perpendicular lines. Parallel lines are lines having the same slope. Given two lines of slope m1 and m2, two lines can only be parallel if and only if the slope of the first line is equal to the slope of the second line. That is, both lines have the same value of the ratio of their rise over run. Perpendicular lines are lines whose slopes are negative reciprocals of each other. Given two lines of slope m1 and m2, two lines can only be perpendicular if and only if our m1 is equal to negative 1 over m2. Angle between two lines. Two intersecting lines form two pairs of equal angles, and an angle of one pair is the supplement of an angle at the other pair. We shall show you how to find a measure of each angle in terms of the slopes of the lines. Considering phi plus theta 1 is equal to theta 2, leading us to phi is equal to theta 2 minus theta 1. Using the formula for the tangent of the difference of two angles, we will find tan phi is equal to tangent quantity of theta 2 minus theta 1. Now, in our second line, here, we will apply the identity of the tangent for the difference of angles, which will give us tan theta 2 minus tan theta 1 all over 1 plus tan theta 1 tan theta 2. If we let m2 equal to tan theta 2 and m1 is equal to tan theta 1, then we have tan phi is equal to m sub 2 minus m sub 1 all over 1 plus m sub 1 times m sub 2. Our m sub 2 is the slope of the terminal side, and m sub 1 is the slope of the initial side, and the phi is measured in a counterclockwise direction. Important thing to remember, this formula will not apply if either of the lines is vertical, since a vertical line does not possess slope. For this case, the problem would be that of finding the angle, or a trigonometric function of the angle, that a line of known slope makes with a vertical. Hence, no new formula is needed. For two slant lines that are not perpendicular, it will yield a definite number as the value of tan phi. Conversely, if the slopes of the line are such that the formula yields a definite value, the lines could not be perpendicular, because the tangent of a right angle does not exist. Since the formula fails to yield a value only when the denominator is equal to 0, it appears that the lines are perpendicular when and only when 1 plus m sub 1 times m sub 2 is equal to 0. Let us take this one as an example. Find the interior angles of a triangle with vertices at 1, 1, 4, 3, and 5, 2.